Okay, welcome everybody. Let us try to solve this indices question, complex indices question for senior secondary school students, grade grade 11, grade 10, grade 11, and grade 12. Those who prepare for WAEC examination and any other external examination like NECO and JAM, you will see questions like this. So how do we solve it? It's a complex indices question. So the first thing to do is you look at it very well. You say this is a perfect square, this is also a perfect square, this is 9, this is 4, this is 18, this is 2, I think this is a small base. You can see this 2 raised to the power of n. So we have a small base here. Then this is 12. Now if you look at them very well, most of them are not perfect squares. So what do we do to them? Like these two, my idea, I'm going to target 2 and 3 as the base in all the values that I'm going to have here. So I'm looking at powers of 2 and powers of 3. So let's look at 6. 6 can be written as 2 times 3. Then raised to power 2n plus 1. Then we know that 9 in powers of 3 is 3 raised to power 2. 3 times 3 is 9. So we have 3 raised to power 2. We are raising a power to meet a power. So we have 3 raised to power 2. The 2 is going to multiply n, because that's the rule. When you raise the power to meet a power, you multiply the powers. Then let's see 4 in powers of 2. You know we can't get 4 in powers of 3, but we can get 4 in powers of 2. So let's see 4 in powers of 2. 4 in powers of 2 is 2 raised to power 2. So we have 2 raised to power 2. And there's a power already outside there. How we have seen that? 2n. So times 2n all over 18. Let's look at 18. 18 we can multiply, we can get the perfect square in 18. I think 2 times 9 is 18. So let's start from there. So we have 2 times 9 raised to power n. I will come back to that. Then times 2 raised to power n, 12. 3 times 4 will give you 12. So let's say 3 times 4 raised to power 2n. We are not done. If you look at this, we still have something to do here. So now let's solve the numerator. Look at the numerator. I can use the law of indices. On this numerator. We know that from the law of indices, when we have let's say we have m raised to power a times m raised to power b becomes m raised to power a plus b. Please look at it. M raised to power a times m raised to power b becomes m raised to power a plus b. Now observe this. I can split this value. I can spread this power. I'm coming to that actually. Let me first of all spread the power. This is the same thing as saying 2 raised to power 2n plus 1 times 3 raised to power 2n plus 1. Please, I'm just spreading the power. We're not applying the law of the indices yet, but let's keep that law. Then times, let's multiply 2 times n is what? 3 raised to power 2n times 2 times 2n, 2 raised to power 4n, all over this, all over. Now let's see. How do you know that 9 in powers of 3 is 3 raised to power 2? So I have 2 times 3 raised to power 2n, then times 2 raised to power n. Then how do you know 4 in powers of 2 is 2 raised to power 2? How do you know that 4 in powers of 2 is 2 raised to power 2? So we have 3 times 2 raised to power 2 times 2n. Hope you have seen that. So let's see. If you look at the one on top, you look at the numerator. We can collect like terms at the numerator. So there I can say 2 raised to power 2n plus 1. This is the like term. Times 2 raised to power 4n times 3 raised to power 2n plus 1 times 3 raised to power 2n all over. Then let's look at the numerator. We still have some unfinished work there. So at the numerator, I can expand this You see, let me spread these powers. This is 2 raised to power 1. So I'm going to say 2 raised to power 1 times n, which is 2 raised to power n. 3 raised to power 2 times n. You know, when you raise the power to meet the power, you multiply. So 2 raised to power 2 times n, which is 3 raised to power 2n. Then times 2 raised to power n. Then this is 3 raised to power 1. 3 raised to power 1 times 2n. 3 raised to power 2n. Times 2 raised to power 2 times 2n is 2 raised to power 4n. I hope you have seen that. So let's move on. Now, recall this law. M raised to power a times m raised to power b equals to m raised to power a plus b. And let's use it on the numerator. This is 2 raised to power 2n. They are like terms. No, you can see that they have the same base. So I will add the powers from that first law. So I'm going to have 2 raised to power 2n plus 1. Because I'm going to take one of the base. They are the same. Then add the powers. So plus 4n. Then times 3 raised to power 2n plus 1. This, you see, they are the same. The same base. So add the powers. 3 raised to power 2n plus 1 plus 2n. All over. Let's look at the numerator. We still have some work to do in the numerator. So let's try to solve it gently. You can see the like terms there. These are the same base. So I want to take them together. So we have 2 raised to power n. We have 2 raised to power n times 2 raised to power n times 2 raised to power 4n. Then times 3 raised to power 2n times 3 raised to power 2n. It makes the work easy for you. I hope you have seen that. So then let's also apply the first law there. But let's try to solve the numerator. We can still solve this. 2n plus 2n. We have 2 raised to power 6n plus 1 because 2n plus 2n plus 4n is 6n. Then times 2n plus 2n is 4n plus 1. All over. Now I can, you see, they are the same base. We have common base. So if we have common base, add the powers. So I can just take one of the base and add the power. So we have n plus 4n. Then likewise this 3 raised to power 2n plus 2n. We are going somewhere. Observe. Then what do we have next? Let me try to solve this. Let me simplify it completely. This is 6n plus 1 times 3 raised to power 4n plus 1. All over. Let's solve. What's n plus n? Plus 4n is 6n. I hope you have seen that. n plus 4n is 6n. Then times 3 raised to power 4n. I hope you have seen that. Okay, now observe. You can see that we're almost there. This is divided by this. This is divided by this. They are like terms. They are like terms. So what I'm going to do, I'm going to look at this second law. M raised to power a, when the bases are common, then you subtract and you are dividing. Then what you do, subtract the powers. Now, you know this, they are dividing. This is actually, I want to put it in bracket to make it simple, easy for you. I can say 2 raised to power 6n plus 1 is being divided by 2 raised to power 6n. Now, multiply, even if I don't put this sign multiplication, hope you know you have 2 brackets, it's multiplication. Then 3 raised to power 4n plus 1 is being divided by 3 raised to power 4n. So what's next? Let's solve it. Then I can have, what can I have there now? Let's see. You know, they are the same, they are common base. So I'm going to have 2 raised to power. I'm going to subtract the powers. 6n plus 1 minus 6n. How do you know that? 6n plus 1 minus 6n. Then let's look at this other side. What do we have there? 3 raised to power 4n plus 1 minus 4n. We are moving. So we can solve that. Please. Let's complete the work at this side. Let's complete the work here. Finally, I have 2 raised to power 6n minus 6n plus 1 times 3 raised to power 4n minus 4n plus 1. 6n minus 6n is actually 0, so we have 2 raised to power 1. Then 4n minus 4n is actually 0, so we have 3 raised to power 1. What did you observe? You know that 2 raised to power 1 is what? 2 raised to power 1 is 2. 3 raised to power 1 is 3. The final answer is 6. You have A1 in mathematics in WAEC.